Welcome everyone. We're going to look at power analysis. Okay. Um, this session actually follows a session that we have had on sampling. We realize that in sampling, we basically pick um, members of a given population, and then we collect data from those members. The members that are supposed to be representative of the whole population, and from which we collect data from. Those are the ones we call the samples. So, um, how many members of a given population can you pick, or how do we say that then this given number of members in a sample is actually representative of the general population? The answer to this question is not one. There are different considerations that we have to take, that we have to look into for us to make that kind of conclusion. So one of those things that we have to look at is what we call power analysis. So it is a statistical concept that helps us to determine the appropriate sample size in order for us to achieve statistical significance and minimize any chances of committing either type 1 or type 2 errors. So in simple terms, we are saying that power analysis is a statistical tool that can be used to determine the sample size that is needed to achieve a desired level of statistical power. Statistical power is basically a term that explains the probability of detecting a true effect or the true difference between groups if you're making a comparison at a given level of confidence, or at a level of alpha and effect size. So we are going to look at this in details, but basically what statistical power basically talks about is that there can be, for example, if you are interested in detecting whether a given drug can actually result into reduction in body temperature. Okay, so that reduction in body temperature is the effect that you're interested in, but is that effect actually truly existing, or it is because of other things? Okay, that is what we call the true effect, and the probability of detecting that true effect is what we call statistical power. Okay, so we need to understand some key concepts clearly, such that we can understand the whole concept of power analysis. The first concept that we have to look at is type 1 error, which we call alpha. It is the probability of rejecting the null hypothesis when it is actually true. Okay, so a null hypothesis, for example, is when you say that um, there is no difference in in an intervention, or there is no difference, or there is no effect caused when you give a person drug X. Okay, so that is a hypothesis. You've set out that statement. You don't know whether it is true or false, but you're saying that it has no impact whatsoever. Okay, so that statement can either be correct or false. Okay, so now when you reject it, when you reject that statement that it is actually false, when it is actually true, you're committing a type 1 error, which you call alpha. And then a type 2 error, beta, is actually the probability of accepting a null hypothesis which is actually false. So you're accepting something that is not true, but you're accepting it as something that is actually true. Okay, and then the term power is basically the probability that you can correctly reject a null hypothesis when it is false. This is what we want. Okay, when a null hypothesis is false, we should reject it. So if you correctly reject it, then then you're doing something that is actually right. So the probability of correctly rejecting a null hypothesis when it is false is called power. The next term that we have there is what you call significance level. Okay, significance level. Significance level is the probability of rejecting a null hypothesis when it is true. So you choose, you basically believe that, okay, I'm conducting this study, but there are chances that I may actually be wrong. So what are those chances? Is it 1% chance that you can be wrong, or is it 5% chance that you can be wrong? Okay, so what is that probability of you rejecting something, rejecting a null hypothesis when the hypothesis itself is actually true? Okay, and then we have the effect size, which is basically the magnitude of the difference or the magnitude of the association between two groups or variables. Okay, so for example, if you are giving two groups of the research participants, you're giving them drug X and drug Y. So what is the difference in terms of impact of drug Y on one group and drug X on the other group? That is the effect size. Okay, so this alpha, which we said is type 1 error, you can choose, there are basically two options that are conventionally used for this. It is very important for you to know this alpha and beta and what values are assigned because they actually play an important role in the calculation of power or the calculation of power analysis. So that is why it is very, very key. So alpha is usually set conventionally at 0.05 or 0.01. Okay. This therefore means, in simple English, is that if you're going to choose one of them, either 0.05 or 0.01, okay. When you choose any of those, you're basically meaning that you're willing to accept that there will be either a 5% chance or 1% chance of rejecting a null hypothesis when it is actually correct. Okay, that is what you're stating in your study. Okay, now when you set the alpha value high, okay, when you set it too high, you're increasing the likelihood that you will have what you call false positive results. False positive results. It means that you'll be able to detect, you'll be detecting an effect, yet that effect is not actually present. That's what you call a false positive result. Okay. So, but when you set it too low, when you select a low alpha value, you increase the risk of having false negative results. False negative results are those where um, you have the effect, but for you, you're saying the effect is not there. That's a false negative result. So you need to choose the appropriate alpha value, whether it is 0.05 or 0.01. You need to make an informed decision on which one you have to take. And this actually depends on the nature of the research designs that you're having, the research questions, and other ethical considerations about your study. Beta, which is inversely related to power, which means that if you increase power, decreasing the risk of committing a type 2 error. Okay, so you also need to choose the appropriate level of beta. Okay, so the beta values that are commonly used are 0.10 and to 0.20. Okay, when you do that in simple English, it means that you are willing to accept that there are either 10% or 20% chance of committing or accepting a null hypothesis when it is actually false. Okay, yes. So uh, power is also typically set at 0.8 or higher, which basically means that you, as a person conducting a study, you want to have an 80% chance of detecting a true effect or any difference between groups. Remember, power is the probability of detecting a true effect. Okay, so you can choose a value to say that for this study that I'm conducting, the power that I've set this to is 0.8. And when I say 0.8, I'm meaning that I have 80% chances of detecting a true value. So the power itself is actually influenced by the alpha, beta, and then effect size and sample size, and also the variation of the variability of the data set. Okay. So if you increase the sample size, the effect size and alpha, you're basically decreasing, just a minute. I think leave that out, leave that concept out. Effect size, which we said that that effect that you're actually trying to detect. Okay, it should be like your as a researcher, you should be able to detect it when it actually occurs. That is your interest. So how do you express effect size? There are many constants that you can use in doing that. Okay, but basically, if you have small effect sizes, for this, you stop at beta. Stop on the beta slide. Yes, stop on beta slide.